Hello guys, welcome back again to another video of your class 11 mathematics. In today's video, we should learn about a topic known as your limits and derivative. Limits and your derivatives, which falls under your chapter 13. Okay, this limit and derivative is the beginning of a topic known as your calculus, which we're going to study more on your class 12. Okay, and as your calculus is the basic maths, without calculus I would say that there is no maths. Simple as that. Okay, so let me begin with your chapter 13. So first of all, let me just start with your exercise 13.1. Before I begin with your 13.1, we should know what is a limit. So I will just say your concept of limit. The concept of your limit. All right. Now, let me just say that let your function, any function, let f of x is equal to your x squared minus 1 divided by x minus 1. Now, over here, I got x squared minus 1 divided by your x minus 1. So clearly, I can say that whenever your x happens to be 1, then the value for your fx would be nothing more than your 1 squared minus 1 divided by your 1 minus 1. Or in short, I can write down here 1 also. So I'll be getting something like that. So which is nothing more than 0 divided by 0. So which we called nothing more than your indeterminate value, or in short 0 by 0 is nothing more than your meaningless value. Okay, so we cannot get an answer like that. So I would just simply say that thus your f of x is not defined. It's not defined at nothing more than your at x is equal to your 1. So what can I do more is your f of x, I can simply say that I got x squared minus 1 divided by x minus 1. So I can just simply convert this one to x plus 1, x minus 1 divided by x minus 1. So I can cancel this and that. So I'll get here f of x is nothing more than your x plus 1. This will happen only when your x is not equal to your 1. Otherwise, the answer will be 0 by 0. So I got till there. Now, let me just write on next page the same thing. I got your f of x to be nothing more than your x plus 1, and x is not equal to 1. So if x is not equal to 1, so we can say that if we give to x a value not exactly 1, not exactly 1, but slightly, yeah, but slightly more than 1, then clearly we will instead of we will, I will just say clearly the value of f of x is slightly more than 2. Now you might be wondering, I'm over here, I've written down here slightly more than 1 and I've written slightly more than 2. What do you mean by it? Let me just try to elaborate with a table. What do you mean by slightly more than 1 and slightly more than 2? So let me just give a table and say the first one is nothing more than your table. First one is x and then your f of x. So suppose I took the value for x slightly more than 1. Suppose I say that it's 1.1, slightly more than 1. Then the value for f of x will be 1.1 plus 1 is nothing more than your 2.1, which is slightly more than 2. And as I go on, what do you call, decreasing the value for x like this, 1.01, I'll get here 2.01. Even the value for f of x is decreasing, and similarly 1.001, that will be nothing more than 2.001, and so it goes on. So if it goes on, let me just go with another big number, 1.000001, that will be nothing more than 2.00001. So I'll be getting this one, and so thus it goes on. So what can I say from here is that thus as the value of as the value of x approaches to 1, it means it's not equal to 1, but it's trying to get nearby 1. The value of f of x approaches to 2. So we write we write this one as nothing more than x, an arrow with 1, or your f of x, an arrow with 2. So it's x approaches to 1, f of x approaches to 2. So this arrow, it is called nothing more than your tends to. Don't forget this one, okay? So what we call over here is as x tends to 1, your f of x will tends to 2. So this is nothing more than the first one, which we did slightly more than 1. But we cannot say that the value would be actually slightly more than 1. It might be slightly less than 1 also. So let me go with that again. So similarly, uh, if we give to x, a value slightly less than 1, then the value of f of x will be slightly less than 2. And what do you mean by it? Again, let me just draw the table. So if I happen to draw the table, do remember your f of x is nothing more than your x plus 1. So let me just draw a table over here. So if I happen to take the value for x and then f of x, yeah, if I happen to take the value for x slightly less than 1, suppose I say 0.9, then the value for f of x will be 1.9. And as I go on increasing the value for x like 0.99, the value for your f of x also increases, which becomes nearer to 2, which is nothing more than your 1.99 again. And similarly 0.999, that will be nothing more than your 1.999. And so this goes on. So let me go with a bigger number. Let me just say 0.99999, 1.99999, and so does it goes on. Now I can say that thus in this case also, as x approaches to 1, your f of x approaches to 2, approaches near to 2. So which is same thing as x tends to 1, your f of x tends to 2. So we express the above two thing that we've done for slightly less than 1 and slightly more than 1. So we express the above as nothing more than limit of x tends to 1, your x squared minus 1 divided by your x minus 1 will be equal to 2. So in short, if I happen to give you the definition for limit, it will be hence we say that for limit, okay, limit of x tends to a, f of x is equal to L if whenever your x tends to a and your f of x tends to L. That is the definition for your limit. Now that's all about your limit. You can pause the video and then check once again from the beginning if you didn't understand. So there are some theorems regarding this limit. So let me just go with some theorems. The first theorem is nothing more than your limit of x tends to a, x to the power n minus a to the power n divided by x minus a is equal to nothing more than your n, a, n minus 1. Similarly, for number 2, your limit of x tends to 0, your sine x divided by x is nothing more than 1. And for number 3, it's nothing more than your limit of x tends to 0, 1 minus cos x divided by x is nothing more than 0. So these are the three limits that, so not limits, these are three theorems that you should know. All right. All right then, let us start with your exercise 13.1. So let me just right away start with your question. It's given that evaluate the following limits in exercise 1 to 22. So let me just start away with first question, number 1. It's given to be limit of x tends to 3, your x plus 3. So what I have to do is that in the next step, just put the value for x, whatever is given. Over here, the value for x is given to be 3. So just put it over there so that in the value for x, that will be 3 plus 3, which is nothing more than 6. And in a similar way, number 2 also is given that limit of x tends to pi, and I got here x minus 22 by 7. So over here also same thing, the value for x happens to be nothing more than pi. So simply put the value for x over here, so which would be nothing more than pi minus 22 by 7. So till now we have been doing and we're getting the answer in a quite easy manner. So let me just do your question number 4 again. Your question number 4 is given to be your limit of x tends to 4 and then your 4x plus 3 divided by x minus 2. Okay, whenever you got a numerator and a denominator, always at the rough check the denominator first, okay, and then put the value for x. Over here, if you put the value for x at your denominator, you will get nothing more than 4 minus 2, which would be 2. Suppose you got in a denominator like 4 minus 4 and you got the answer 0, that means you cannot solve further, okay? So you have to do in a different manner. But over here, I'm simply getting your denominator to be 2, so that means you can solve. So you simply put on the value, so which would be 4 into 4, 4 into 4 plus 3 divided by 4 minus 2, which would be 16 plus 3 divided by 2, nothing more than your 19 by 2. So I got this one. So that's all about your question number 4. Now let me move ahead with your next question. That's nothing more than your question number 7. Let me just go with your question number 7. So over here again, same thing is given to be limit of x tends to 2. I got here 3x squared minus x minus 10 divided by your x squared minus 4. Again, the same thing, I got numerator and denominator, so always check the denominator first and try not to get 0, okay? So if you happen to put a value for x at the denominator, we'll get here 2 squared minus 4, which is 4 minus 4, and that's nothing more than 0. All right, I got the answer to be 0, so which is not possible, because anything divided by 0, the answer will be undefined, and I don't need the answer to be your undefined. So what we have to do is that we will do in such a manner, we'll try to remove this one, so that our answer wouldn't be 0, okay? Forget about the numerator, but our main objective is to solve the denominator in such a manner that the answer wouldn't be 0. So how to do that? It's a very simple thing. It will be, I would say that you have to solve the numerator, and in very simple term, I'll just say you have to solve the numerator by using splitting the middle term. So there will be nothing more than limit of x tends to 2. Then I'll get here, if I split the middle term, I'll get the answer x minus 2 divided and then 3x plus 5. You can do directly also, and similarly at the denominator, I'll get the answer because it's about x squared minus 4. So x squared minus 4, it means nothing more than x squared minus 2 squared. So which will be x plus 2, and then I'll get here x minus 2. So let me just simply cancel x minus 2, x minus 2. Now if you put the value for x is equal to 2 at the denominator, you're not getting it to be 0. So the answer would be 3 into 2 plus 5 divided by 2 plus 2. So which is nothing more than 3 to the 6, 6 plus 5 is 11, and 2 to the 2 plus 2 is 4. So that's your answer. So that's all about your question number 7. Now, if you didn't got till now, let us try to solve in a similar manner your I would just say your question number 8 and then see whether we are clear with that or not. So your question number 8 is given to be limit of x tends to 3, and I got the x to the 4 minus 81 divided by 2x squared minus 5x minus 3. I got till there. Now again the same thing, just look at the denominator first. So if you just simplify the denominator and put a value for x, we'll be getting the answer 2 into 3 square minus 5 into 3 minus 3, which would be 9. 9 to the 18 minus 15 minus 3. The answer would be 0. Now again the same thing, we don't need the answer 0 at the denominator. So what we can do, the next step is I'll just get a limit x tends to 3. Then I'll do this one to be x4 I got, so I can simply do that in x2 the whole thing square and then 9 square. So, and the denominator, let me just again split the middle term, so there'll be 2x squared. Let me just do slowly over here in this question. So which will be 6 minus 1 x minus 3. So that will be your limit of x tends to 3, so which is x squared plus 9, and then that will be x squared minus 9 again. So again that will be 2x squared minus 6x plus x minus 3. So that will be your limit of x tends to 3. I got here x squared plus 9. Now I got here x squared minus 9, which I can say 9 means 3 squares. So that will be your x plus 3 and then your x minus 3. Now again the same thing over here. I'll get here 2 and sorry That's not 2, that's 2x, and you'll get x minus 3 plus 1, and then your x minus 3. So let me just try to solve it over here. So which would be limit of x tends to 3, I'll get here x squared plus 9, and I'll get here x plus 3 and x minus 3 divided by 2x plus 1, and then I'll get here x minus 3. Now what can I do is that I can simply cancel your x minus 3 and x minus 3, because this is a thing that's making us the denominator to be 0. Now in the next step, just put the value for x, which would be 3 square plus 9, and then nothing more than your 3 plus 3 divided by 2 into 3 plus 1. So 3 square is 9, 9 plus 9 is 18. So that will be your 18 into 6 divided by 2 is 6, 6 plus 1 is 7. So which is nothing more than your 108 by 7. Okay, so that's all about your question number 8. All right, again, I forget to mention over here is that whenever you are putting the value for x over here, remember, in the next step, there won't be any limit because you have already put the value for x. Okay, so don't make a mistake over here by putting limit again over here and then giving here x tends to 3. Your answer will be very wrong. Clear till there? Because you have already put the value for x. So there won't be any limit over there. So okay, so that's all about your question number 8. All right, now in a similar manner, let us try to solve your next question. Let me go with your question number 13. Your question number 13, it's given to be nothing more than limit of x tends to 0. I got here sine ax divided by bx. Now, before I go further with this question, we already know that the formula, okay, let me just write the formula, that limit of x tends to 0, your sine x divided by x was nothing more than 1. Now, same thing, instead of sine x, I got nothing more than your sine ax. So what I'm going to do with the next step is, I'm just going to write down like this, limit of x tends to 0. I got here sine ax. Now if you can look, I got here x, I got here x, and this is also x, and the answer is 1. But I got here ax. That means I have to divide it by a, and then x. So if I divide by a, I should multiply a, and I got b already, so that's b. Now if you look again with the formula, I got here x, x, and I got here x again. But over here I got nothing more than your ax, and I got here ax. That means this is also should be ax. And same thing, if x tends to 0, suppose that if x happens to be 0, no matter what you multiply over here, the answer would be 0 only. So instead I can say ax tends to 0. So I'm just going to put here a, and let me just give in bracket. So in short, the answer is 1 into a by b, which is nothing more than your a by b. And how did I got it? Look at the formula. All right, so that's all about your question number 13. Okay, now if you're not clear with 13, okay, let me try with question number 14 in a similar manner. Yeah, question number 14 is given to be limit of x tends to 0. I got here sine ax divided by sine bx. So same thing, the formula is again limit of x tends to 0, sine x divided by x is equal to 1. So I got, instead of x, I got here nothing more than your ax, and I got here nothing more than your bx. Okay, before I solve further, let me just divide limit between them. So there will be limit of x tends to 0. I got here sine ax divided by limit of x tends to 0, sine, I got here bx. Now, as I said over there at the formula, it's x divided by x, so that will be nothing more than divided by ax. Now if I divide by ax, I have to multiply with ax, and similarly divided by bx. If I divided by bx, I have to multiply with bx. So again, same thing, I'll just put here a, I'll just put here b, let me give in bracket, and this one also in bracket, and over here I can cancel x with x. So in short, I'll get the answer 1 into a divided by 1 into b, which is nothing more than your a by b. Okay, now if you didn't understand, you can pause the video and check once again. All right, so that's all about your question number 14. Now, in a similar manner, let me go ahead and do your next question. Let me go with your question number 18. Let me go straight away go with your question number 18. Your question number 18 is given to be limit of x tends to 0, and I got here ax plus x cos x divided by b sin x. Now over here I got so many terms. If I happen to put the value for x to be 0 at the denominator, I'll get here sine 0. Sine 0 is nothing more than 0, and as I said, I don't need 0 at the denominator. So what can I do with this one is, I got here limit of x tends to 0. I'm simply gonna take from the numerator x common. Okay, so if I take x common, I'll get the answer a plus cos x and divided by b sin x. Now, what I will do with the next step is I'm gonna distribute limit accordingly. By distributing limit accordingly, it means I'm just gonna make in this manner. The first thing I got b, and that's the denominator. I got 1 by b. Then I'll be limit of x tends to 0. I got here x divided by your sine x into limit of x tends to 0. Then I got here a plus cos x. So I distribute your limit accordingly by the solvable answer over here. Okay, so that means the next step I can go over here is, we know the formula for limit of x tends to 0, sine x divided by x is 1, but we don't know about your x divided by your sine x. So what I'm going to do over here is I'm going to bring this x down, and what I mean by it is a by b, I can write down this one to be nothing more than 1 divided by b by a, the same thing, because this will come up. So what can I do with the next step is, I'll just give this one to be 1 divided by, it will be limit of x tends to 0. I got here sine x divided by x into limit of x tends to 0. I got here a plus cos x. So I'll get here 1 by b into 1 by 1, because the value for this one would be nothing more than 1. So I got 1 by 1. Then into limit of x tends to 0 a, there's no x, so there will be a, and limit of x tends to 0 cos x would be nothing more than, if I put the value for x to be 0, it will be cos 0. Cos 0 is nothing more than your 1, or instead let me just write down here cos 0, better. So which will be 1 by b, and I'll get here a plus 1, and that is your answer for nothing more than your question number 18. Okay, so that's all about your question number 18. Now, in a similar manner, let me just move ahead with nothing more than your question number 23. Now, before I do your question number 23, let me just try to give you what actually it's your limit under definition. Okay, so I'll just say your limit. The definition was nothing more than limit of x tends to a, your f of x happens to be L. Now this limit also can be divided into two parts. And what I mean by two parts is, if you can just see, we did slightly less than 1 and we did slightly more than 1 in the beginning. So when we did slightly less than 1 and slightly more than 1, both the answer tends up to be in a similar manner, which is nothing more than, I would say, over here your L. So same thing, this limit has to be divided into two parts. The first one would be your limit of x tends to a minus f of x, which is for slightly less than 1, and similarly it will be limit of x tends to a plus your f of x, which is slightly more than 1, and these two limit must be equal, and this must be equal to your L. And whenever we happen to be that means we can say that this the limit exists. Okay, now what do we call this one? This one is known as your left hand limit, which in easier term we're going to write on LHL, and this one is known as your right hand limit, which in easier term it will be nothing more than your RHL. So if I combine everything, this and then this, so we can say from this two that is the definition for your limit. I would say mathematically it will be nothing more than your limit of x tends to a minus f of x is equal to limit of x tends to a plus f of x equal to limit of x tends to a f of x equal to your L. So that's all about your mathematical definition of your limit. So your left hand limit should be equal to your right hand limit all the time. Okay, so that's all about your limit. Okay, as I said, we're going to start with your question number 23, sorry. So let me just go ahead. Your question number 23 is given to be find. Okay, find limit of x tends to 0 f of x and limit of x tends to 1 f of x, where your f of x was given to be 2x plus 3 and then 3x plus 1. I got the first one to be x less than equal to 0 and the next one to be x greater than 0. Now, how to do this one? I got till there. So first of all, I have to find for limit x tends to 0 f of x. Okay, so let me just say for x is equal to 0, the first one will be limit of, I have to find limit of x tends to 0 minus your f of x. Okay, so limit of x tends to 0 minus f of x, it means 0 minus is less than 0. It's not greater than 0, slightly less than 0. So that will be less than 0. So the next step would be limit of x tends to, now just write down here 0 because I'm doing it for your 0 minus. So the minus indicate is less than 0. So less than 0 means the first one, which is x is less than 0. So just put the value, which will be your 2x plus 3. So if you can look, I didn't write here minus because for this minus, I just wrote the value over here. So I'll get here. Remember, the value for x is nothing more than 0. So there will be 2 into 0 plus 3, which is nothing more than 3. In a similar manner, your limit of x tends to 0 plus your f of x. Now I got plus. Plus it means 0 plus it means it is slightly greater than 0. So which is nothing more than greater than 0. Now for greater than 0, this one, it's this one, x is greater than 0. So which would be nothing more than limit of x tends to 0. I'll get here 3 and then x plus 1. Remember, for plus, I have written down here the value, which is your 3 and then x plus 1. That's why over here I didn't write any plus. Now put on the value for limit, that is x tends to nothing more than 0. So x is equal to 0. So that will be 3, 0 plus 1, which is nothing more than 3. And lastly, for limit of x tends to 0, that means x is equal to 0, your f of x, I'll be getting for equal to, there's a sign over here, equal to. So that will be the first one. So that is limit of x tends to 0. I'll got here 2x plus 3, which is nothing more than 2 into 0 plus 3. I got here 3. So I can say that, therefore, your limit of x tends to 0 minus f of x is equal to limit of x tends to 0 plus f of x is equal to limit of x tends to 0 f of x, which is nothing more than, I got it to be 3. So that's all about your when x is equal to 0. Okay, now let me go ahead with your next one. So let me just go to your next page. So let me just write the question first. I got here f of x is equal to your 2x plus 3, and I got here 3x plus 1. X is slightly less than 0, or equal to 0, x is greater than 0. Now I have to find for when x is equal to 1. So that is your limit of, first I have to find x is greater than, oh sorry, x tends to 1 minus f of x. Now, for 1 minus, it means it is slightly less than 1, but it is greater than 0. It is less than 1, which is greater than 0, which I can say 0.999. See, that is less than 1, but is greater than 0, right? Slightly less than 1, but greater than 0. So for or this one also, the value would be greater than 0, so that is nothing more than 3x plus 1, which is nothing more than 3. 1 plus 1 is equal to 2, because the value for x happens to be 1. And for limit x tends to 1 plus f of x, for 1 plus f of x, again it's slightly greater than 1, so slightly greater than 1, obviously it will be greater than 0. So it will be limit of x tends to 1, again 3x plus 1 is equal to 3, 1 plus 1 is equal to, oh by the way I wrote it wrong over here, that should be 6, my bad. 6, and over here also I get your 6. And lastly, limit of x tends to 1. Limit of x tends to 1, your f of x. That means x is equal to 1. When x is equal to 1, again, it means that your x is greater than 0. So if it's greater than 0, that means I have to write on something again. So limit of x tends to 1, 3 of x plus 1, so which is again 3 of 1 plus 1, nothing more than 6. So over here also, therefore, limit of x tends to 1 minus your f of x will be equal to limit of x tends to 1 plus f of x equal to limit of x tends to 1, your f of x, which is nothing more than 6. Okay, so that's all about your question number 23. Now, again, I'm going to say the same thing. If you didn't understand, you're always welcome to pause the video and check nicely. And okay, so that's all about your question number 23. Now let me just move ahead and do with the question, which is a little bit interesting, I would say. Yeah, let me go with your question number 28. Now, question number 28 is given that suppose your f of x is nothing more than the first one I got to be a plus bx if x is less than 1, and I got 4 if x is equal to 0, and b minus ax. Oh, by the way, it's not equal to 0, that's equal to 1 only, and b minus ax if x is greater than 1. And it's given that and limit of x tends to 1, your f of x is equal to f of 1. What are the possible values of a and b? Very nice question. So what can I do it from here is that, first of all, let me try to find out the left hand limit, okay? Remember, the value for x is nothing more than 1, so left hand limit, it will be limit of x tends to 1 minus, that's given, which will be f of x. So x tends to 1 minus. 1 minus, it means it's slightly less than 1. Less than 1, I'll get the value to be limit of x tends to 1, the first one, a plus bx. Now simply put on the value for x, which would be a plus b. I got till there. Then let me go with the right hand limit, so which is nothing more than limit of x tends to 1 plus. 1 plus, it means greater than 1. So limit f of x, which is limit of x tends to 1, so greater than 1, it means the third one, this is the one, which would be nothing more than b minus ax. So if I put the value for x, I'll get here b minus a. So I got till there. Then given, let me write down something. Given, what is given over here is limit of x tends to 1, your f of x is equal to your f of 1, which I've already written down over here itself, if you can look, and it's given at your question also. So if I say this one, let me go to your next page and then write down the same thing. I got here limit of x tends to 1, your f of x is equal to your f of 1. Then let me just check how much is your f of 1. When x is equal to 1, I got the answer to be nothing more than 4. Remember that, okay? So if I got the answer to be 4, what can I do over here is, for this one, I can break this one into limit of x tends to 1 minus f of x is equal to limit of x tends to 1 plus f 1 plus your f of x. That's the definition for limit. So I break this one into your two parts. That's your left hand limit and your right hand limit. But this one, I got f of 1 is, which is nothing more than I got the answer to be 4. If you can see, when x is equal to 1, the answer is 4. So I got till there. So let me just put on the value for left hand limit. How much I got? A plus b. And for your right hand limit, I got it to be b minus a is equal to 4. So if I happen to solve this one, what can I do? I can simply say that that is your a plus b is equal to 4 and your b minus a is equal to 4 again, by taking the first and third part and by taking the second and third part. So let me just give equation 1 and equation number 2. So adding 1 and 2, we get, so if I add 1 and 2, I'll get here a plus b is equal to 4, b minus a is equal to 4. So if I add them up, that will be 2b is equal to 8. So I got b is equal to 4. And putting b is equal to 4 in equation 1. So if I put that one in equation 1, if I put, I'll get here a plus 4 is equal to 4. So that will be a is equal to 4 minus 4, a is equal to 0. So in short, I got the answer, that is, I got a to be 0 and b to be 4. Okay, now again the same thing. If you didn't understand, you can pause the video and then check once again. So that's all about your question number 28. Again, let me jump to your next question. Let me go ahead and then do your question number 31. Your question number 31 is given that if the function f of x satisfies your limit of x tends to 1, your f of x minus 2 divided by x squared minus 1 is equal to pi. Evaluate or find, same thing, okay? Limit of x tends to 1, your f of x. All right, so how to do this one? So it has been given. So what can I do is that I'll just simply break your limit into two parts, your numerator and your denominator. So the next term would be limit of x tends to 1. I'll get your f of x minus 2 divided by, okay, let me just give the bracket, and same thing, limit of x tends to 1. I got here x squared minus 1, and then I got here pi. Now I will bring this one over here to your right hand side. So the next step I'll get here is limit of x tends to 1. I got here f of x minus 2 is equal to pi, and something, limit of x tends to 1. I got here x squared minus 1. And why did I bring this one to your right hand side is because if I put the value for x to be 1 over here, I'll get in a denominator 0, which we don't want. Okay, so next step, what can I do over here is that I'm going to multiply this with this and then this with that. So if I do that, I'll get the first one to be limit of x tends to 1, your f of x, into, there is no x, so I can simply say that's nothing more than 2. Or, okay, let me just write it nicely then. Limit of x tends to 1, you're 2. Okay, so I got here pi. The value for x happens to be 1, so if I just put the value for x to be 1, I'll get here 1 squared minus 1. So what can I do? The next step is limit of x tends to 1, your f of x. As I said, there is no x over here, so that'll be nothing more than 2. That's tends to, okay, let me down rather nicely. That's x tends to 1. So I got tilde there, and 1 minus 1 is 0, so the answer will be 0. So next thing, what can I do is that I'm just going to bring your 2 over here. So if I'm going to bring the 2 over here, I'll get the answer. That is limit of x tends to 1, your f of x is nothing more than 2. So that's all about your question number 31. Again, same thing, pause the video and check once again if you didn't understand.